Now the capillary tube has to be rubber banded onto the thermometer, and if you use a full-size rubber band, it's too bulky and it's hard to get the whole thing inside of the test tube. So if you take a rubber band, you just put a knot in it to make a little mini rubber band. Okay. Yeah, tie that tight. Then cut it off. And then when you attach the capillary tube onto the thermometer, you want to make sure that the open end of the capillary tube, if I can get the camera to focus there a little bit, you see the open end just barely there. The open end you can feel. The open end should be pointing downward. Okay, like that. This is the apparatus that you'll use to determine the boiling point of an unknown liquid. Right. The apparatus consists of a very special piece of glassware known as a Thiele tube. It's this kind of triangular shaped tube here. And the way the Thiele tube works is it's filled with oil that can be heated to a very high temperature and won't boil. And when you apply heat at this point with the Bunsen burner, the oil that's in there will expand. It will expand, but its mass will not change, so that means its density will become less, and that'll cause it to float upward. So it'll move in this direction along this part of the Thiele tube. By the time it gets down here, it will be cooling down because the heat is being applied only over at this point here, and then it'll begin to sink along this direction. So what happens as you heat the Thiele tube is a creation of what we call a convection current, right? The liquid will be forced to move in this direction, and that will stir the liquid and make kind of a constant temperature in this region here. And that's the special purpose of this piece of glassware. All right, now you can see that I'm heating the Thiele tube. I'm heating it relatively gently, and I'm heating it down at this point where the convection current would be induced. And if you look closely, you can see the conduction current actually. It's being carried along by bubbles going along this direction here, and then the oil cools, and if you look closely, you can see the current moving back up in this direction, like this. Right. Now, inside of the Thiele tube, if you look closely here, you can see there's a test tube, and that test tube has some of the unknown liquid in it. That's the liquid level that you see right where my finger is pointing. The thermometer that's immersed in it has, if you look closely, you can see a capillary tube that's been rubber banded onto it. Right? When you look at the red of the thermometer, you see there's a line coming down. That's a glass capillary tube. It's like a test tube, but it's very thin and skinny. And the open end of the capillary tube is pointing downward, and it's underneath the liquid that's the unknown that you're going to be testing the boiling point of. Now, as I'm heating, if you look over where the capillary tube is, you can see, if you look closely, that there are bubbles that are coming out of the bottom of the capillary tube. From the open end mouth, there are bubbles that appear to be coming out. That's an indication that the unknown liquid is boiling. The best way to determine the boiling point, the most precise determination of the boiling point, is to watch those bubbles and to wait until the bubbles just stop. The temperature when the last bubble just squeezes out of the bottom of the capillary tube is the best, the most precise determination of the boiling point of the unknown liquid. And I see it slowing down here. Getting there. After the last bubble comes out, if you look closely, you will see liquid get sucked back up into the capillary tube. I can just make it out. You see it rising? See, look how the gap means we should record the boiling point right now.